Okay, here are the notes for section 5.1. The title of this section is Inverse Functions. And that is something we'll get down to toward the end of these notes. But before we get to that definition, we start with this definition, what an inverse relation is. So back in an earlier chapter, we would have defined the word relation. And you can think of a relation as just an ordered pair, x comma y. Now, an inverse relation is formed just by exchanging the x and y values. So an inverse relation example might be, well, if I give you this ordered pair, negative 2 comma 5, the inverse of that would be 5 comma negative 2. It's that simple. The next definition is for one-to-one function. A function is one-to-one if different inputs have different outputs. So that's one definition. The textbook definition is more like this, second one. But the way I usually remember it is right here, this third one. A function is not one-to-one if two different inputs correspond to the same output. So some of your questions in your assignment will be to determine if a function is one-to-one. Yes or no. It's a yes or no question. And so I usually start with this. It's a little review. The first question is this even a function? And back in chapter 1 or chapter 2, I would have asked you this, to look at all the x values. Well, all the x values are different, so this is a function. But now today, in section 5.1, I'm going to go a step further and ask you if this is a one-to-one function. So when you're looking for one-to-one functions, not only do you have to look at the x values, well, we already did that. We already looked at the x values, they're fine. Now we have to look at the y values. So are there any repeated y values? And indeed there are in this one. There's a 4 and there's a 4 right there. This is not a one-to-one function. It is a function, but it is not a one-to-one function. In order for this to be a one-to-one function, I could just change this last y value to something different. Then that would make it a one-to-one function. And I'll have a few more examples of that coming up. The next thing, there's two more things in this section. The next thing is the horizontal line test. And so this goes something like this. If every horizontal line intersects the graph of a function in at most one point, then it is a one-to-one function. So in your assignment, if you're asked if something is a one-to-one function, the fast way to decide is if you have a graph. So one of these is a one-to-one function and one of them is not. And so earlier in the course, you would have been given something called the vertical line test. Well, these both pass the vertical line test. These are both functions. A vertical line only hits once. So that's called the vertical line test, and that passes. So that is a function. This one is a function, but it is not a one-to-one function. Okay, so this is a function, it's a quadratic function, but it fails the horizontal line test. The horizontal line would cross in two places. Therefore, it fails the horizontal line test, which means it is not one-to-one. Now this other sketch that I did, this other graph, is it's a cubic function. It is a function. It passes the vertical line test. I can draw any vertical line on there, and it only crosses at one place. So that's no problem. It passes the vertical line test. It is a function. But then to check if it's one-to-one, you think about drawing horizontal lines. And horizontal lines on this graph would only cross once. Therefore, it is a one-to-one function. It's a one-to-one function, and it is a function. It has to be a function in order for it to be a one-to-one function. Okay. So again, looking at sketches is a fast way to go if you're given the graph or if you have your graphing calculator. Okay, so the last little part to the notes is dealing with inverse functions, the title of the section. This is the big part of this. The inverse of a function f of x is denoted. It just means it's written. Okay, this word just means it's written. It's written like this: f to the negative 1 of x. Now, one thing to make a note of is that little negative 1 up there is not an exponent. It's not raising to the power of negative 1. It's just the way math people decided to write the word inverse function. Now this is how it's defined, and that's great if you can memorize it, but it's not the end of the world. You can always look it up if you forget, okay? And we can use this definition to check our answers. This in fact is how we check our solutions, and I'll show you that on some of the examples. I usually don't check the solutions, but you always can. You just have to go back and fill your functions into this little definition. Okay, so 2 more things to make a note of here is that the domain of f of x is the same as the range of f inverse, which, you know, I did allude to on the very first definition. Like if I give you this ordered pair and I said, can you give me the inverse of that, you would say 3, 2, hopefully. And so the domain of the original one, the domain of f of x, was 2, and the range of the inverse is 2. Okay, so the domains and ranges of your original function and your inverse function change place, basically. Okay, so the domain of f of x is equal to the range of f inverse, and the range of f of x is equal to the domain of f inverse. Okay. Now the final thing here, this is actually where most of your work is going to deal with in your assignment. These are the 4 steps to follow when being asked to find an inverse function. Okay, it's pretty straightforward, and I'll do lots of examples of this in the subsequent videos. But the first step is to write it as y equals. Remember, f of x is interchangeable with y. And then the second step, you replace x with y and y with x. So basically you're just interchanging the x and y variables. And then the big one is to solve for y. You have to solve for y. If you do that correctly, you've got your inverse function. Okay, checking it is optional. Like I said, sometimes I'll do that on some of the examples, but I'm not going to do it on some of the more complicated ones. And you'll see what I'm talking about if you watch the other example videos.